Today we are mastering the algebraic methods for circles within the Cambridge International AS and A-level mathematics syllabus. In this lesson, you will learn to express circles in standard and general forms, determine intersections of lines and circles using the discriminant, apply geometric properties to solve coordinate geometry problems. Understanding circles is vital because they form a significant part of the pure Mathematics 1 exam, often appearing in questions that combine algebra with geometric reasoning. By the end of this session, you will be equipped to handle these problems with the precision required for an A-star grade. We begin with the definition of a circle. A circle is the set of all points that are a fixed distance, called the radius, from a central point. We derive the equation of a circle using the distance formula, which is essentially the Pythagorean theorem. If we take the center as point C, with coordinates a, b, and any point P on the circle with coordinates x, y, the distance between them is the radius, r. Squaring both sides of the distance formula gives us the standard form. In this form, the center and radius are immediately obvious. Note that the signs inside the brackets are negative. A circle with center 3, -2 would have a +2 in the y bracket. While the standard form is intuitive, you will often encounter the general expanded form in your exams. This form is reached by expanding the brackets of the standard form and collecting all terms on one side. To revert from this general form back to the standard form, so we can actually see the center and radius, we use the method of completing the square for both the x terms and the y terms. Notice that the center coordinates are half the coefficients of x and y, with their signs flipped. In a Cambridge exam, being able to quickly complete the square is a non-negotiable skill for efficiency. Let's apply this immediately. Suppose we are given the equation x squared plus y squared minus 6x plus 4y minus 12 equals 0. To find the center and radius, we group the x and y terms. Now, we complete the square for both. For the x terms, half of -6 is -3. Squaring it gives 9. For the y terms, half of 4 is 2. Squaring it gives 4. Move the constants to the right side to reach the standard form. Combining the numbers gives us 25. By looking at our result, we can see the center is at 3, -2, and the radius is the square root of 25, which is 5. Always remember to take the square root of the constant on the right. A frequent requirement in pure Mathematics 1 is determining how a straight line interacts with a circle. To find the points of intersection, we solve the equations simultaneously. We have the line equation, y equals mx plus c, and the circle equation, x minus a squared plus y minus b squared equals r squared. We substitute the expression for y from the linear equation into the circle's equation. This eliminates y, leaving us with a quadratic equation in terms of x. Once you have this quadratic, you don't always need to solve for x. Instead, we examine the discriminant b squared minus 4ac to understand the nature of the intersection. If the discriminant is positive, the line is a secant, crossing at two distinct points. If it is exactly 0, the line is a tangent, just touching the circle at a single point. If it is negative, the line and circle never meet. This algebraic test is the most efficient way to prove tangency in an exam. Let's see this in action. We're asked to show that the line y equals x plus 10 is a tangent to the circle x squared plus y squared equals 50. Step 1. Substitute the line into the circle equation. We replace y in the circle equation with x plus 10. Step 2. Expand and simplify. Expanding the bracket, we get x squared plus 20x plus 100. Combining terms, we get 2x squared plus 20x plus 50 equals 0. Dividing the whole equation by 2 simplifies our work, giving us x squared plus 10x plus 25 equals 0. Step 3. Check the discriminant. Here, a is 1, b is 10, and c is 25. We use the formula delta equals b squared minus 4ac. This gives us 10 squared minus 4 times 1 times 25, which equals 100 minus 100, resulting in 0. Since the discriminant is exactly 0, we have proved that the line is a tangent. To find the point of contact, we factor the quadratic. x plus 5 squared equals 0, which gives x equals -5. Substituting this back into the line equation, y equals -5 plus 10. So y is 5. The point of contact is -5, 5. Algebraic methods are most powerful when combined with geometric circle theorems. There are 3 key properties you must master for coordinate geometry questions. First, the tangent is perpendicular to the radius at the point of contact. This means if the radius has a gradient m sub r, the tangent's gradient m sub t is the negative reciprocal. Second, the perpendicular bisector of any chord always passes through the center of the circle. In exams, you can find the equation of the perpendicular bisector of 2 points on the circumference. The center will lie on that line. Third, the angle in a semicircle is a right angle. If AB is a diameter, any point P on the circumference forms a right-angled triangle APB. This implies the gradient of AP multiplied by the gradient of BP equals -1. Knowing these allows you to set up equations without needing the full circle formula initially. Let's solve a typical Cambridge 9709 style question. Problem: find the equation of the tangent to the circle x minus 3 squared plus y plus 2 squared equals 25 at the point 6. 2. Step 1. Identify the center. The equation is in standard form, so the center C is 3 minus 2. Step 2. Calculate the gradient of the radius. The tangent at point 6, 2 is perpendicular to the radius connecting the center to that point. Using the gradient formula, m sub r equals 4 over 3. Step 3. Determine the gradient of the tangent. Using the perpendicular property, m sub t equals -1 over m sub r. This gives us -3 over 4. Step 4. Form the equation of the line. We use the point gradient formula y minus y1 equals m times x minus x1 with the point 6, 2. Subbing in the values gives y minus 2 equals -3/4 times x minus 6. Multiply by 4 to clear the fraction, then rearrange to get 3x plus 4y equals 26. This method is far more efficient than substituting a general line y equals mx plus c into the circle and setting the discriminant to 0. Always look for the geometric shortcut. To secure an A-star grade, you must avoid these frequent errors seen in Cambridge scripts. First, sign errors when identifying the center. Consider the equation x plus 4 squared plus y minus 5 squared equals 9. Students often say the center is +4, -5. Look closely at the standard form. It is x minus a. Therefore, a plus 4 means the coordinate is -4. Always flip the sign you see in the bracket. Second, forgetting to square root the radius. In the equation above, the radius is not 9. The constant on the right represents r squared, so the radius is the square root of 9, which is 3. Third, confusing the gradients of the tangent and the normal. The tangent is perpendicular to the radius. Some students use the same gradient as the radius or forget the negative sign when taking the reciprocal. Finally, incomplete simplification. When solving for intersections, ensure your quadratic is in the form ax squared plus bx plus c equals 0 before calculating the discriminant. A missing term or an uncollected constant will lead to a completely incorrect value for delta. When tackling circle problems in Pure Mathematics 1, keep these examination tips in mind to maximize your marks. First, understand how marks are awarded. Examiners give method marks for correctly substituting a linear equation into a circle equation, even if your subsequent algebra is slightly off. Always show the substitution step clearly. Second, if a question asks you to show that a line is a tangent, you must clearly state that the discriminant is 0. Don't just calculate it. Write down the conclusion, since the discriminant equals 0, the line is a tangent. Third, use the geometric properties we discussed to save time. Finding the gradient of a tangent via the radius is much faster than using the discriminant method if you already know the point of contact. Finally, always check if your final answer should be in a specific form. such as y equals mx plus c or ax plus by plus c equals 0. Failing to rearrange your final equation can cost you an accuracy mark. It is time to test your understanding. Please pause the video now and attempt these 3 questions. Take your time with the algebra. When you are ready, resume the video to see the step-by-step solutions. Let us walk through the solutions to ensure your reasoning is correct. For the easy question, we simply extract the values. Remember to flip the signs. Plus 7 becomes negative 7, and negative 1 becomes positive 1. The radius is the square root of 49, which is 7. For the medium question, we first find the radius squared, using the distance formula between the center and the point. Then, we write the standard form and expand it. Notice the 2005s cancel out, leaving plus 4 as the constant. For the hard question, 2 distinct points of intersection require a positive discriminant. After substituting and simplifying the quadratic, we solve the inequality for k. Remember that when dividing by negative 4, the inequality sign flips. To wrap up our lesson on algebraic methods for circles, here are the essential points to remember for your exam. First, the standard form, x minus a squared plus y minus b squared equals r squared, is your best friend for identifying the center a, b, and radius r. Use completing the square to convert from the general form x squared plus y squared plus 2gx plus 2fy plus c equals 0. To find how a line and circle interact, substitute the linear equation into the circle's equation. Use the discriminant delta equals b squared minus 4ac. Delta greater than 0 means 2 intersections, delta equals 0 is a tangent, and delta less than 0 means no intersection. The gradient of a tangent is always the negative reciprocal of the gradient of the radius at the point of contact. This geometric property is often the fastest way to find the equation of a tangent line. Finally, small sign errors in completing the square or expanding brackets are the most common ways to lose marks. Always double-check your signs, and remember that the constant on the right of the standard form is the radius squared, not the radius itself.